Okay, so what we've got here is a sample of questions that you might be expected to do. It will not cover everything. I've already got a 14 slide thing, so it's going to take a while. So you get a chance to pause the tape, have a go at the questions, and we'll do question at a time. Okay, so we're going to start with trig graphs. So have a go, pause, and then come back when you're ready. Okay, you've had a go, hopefully. We'll just do the first one. So we'll do amplitude, period, phase shift, and we've run out of space, translation. Okay, so the amplitude is just 3, don't worry about the minus sign. The period, the coefficient is 1, so the period is just 2 pi. The phase shift is minus pi on 2, take the opposite, and the translation is minus 4. Okay, have a go at the next one. Amplitude, period, phase shift, and translation. Okay, we'll do the easy one. Translation is just +1. Amplitude is easy, that's just a 2. So I haven't changed the colour. Now, coefficient is 2, so the formula is 2 pi over n, so the period is pi. But to get the phase shift, you have to factorise. So x minus pi on 4 gives us the bracket. And so the phase shift is pi on 4 positive. Okay, so this one up here, that's the phase shift going backwards. Okay, let's move on to the next question. Okay, so we've just got a simple sketch. So when you're ready, please draw. Okay, again, it depends on how. Now, I didn't actually say, so we'll just assume it's just going to be for 360. Okay, so I'm going to draw 3 sine 2x to start with, and then I'll just move it down. Don't forget to label your axes. Now, the sine graph, that's the sine graph. Now, the period is just going to be pi, and at the moment it's 3 and minus 3. Now, the period's pi, which is 180, and I've got to go to 360, so I've got to do another lap. So there's my 360 now, and that's my lap at 180. Okay. Right, so that's what I've done there in that dotted line is 3 sine 2x, and then I've just got to move every point down 1. So 3 becomes 2, and minus 3 becomes minus 4. Okay, and 0 becomes minus 1. So I'm just going to move every point down, every significant point. Okay. So they're all the significant points where they max out or go to 0. So I'll change colours to make it really clear. So that's that point. Oh, wrong colour. I might change it to a darker blue. Okay, that one there, that one there, that one there. Down, 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 and finish back there. Okay. And we only have to go to 360, so we can just sort of stop there. So basically what we've done is we've got like a new sort of x-axis there, but it's not the x-axis, so we've dropped everything down. So that purple line is the right line. Okay, let's move on. Okay, so these are trig equations, some straightforward ones. Second one, 0 less than equal to theta less than equal to 2 pi. So you get some practice with radians and exact values. Okay, so this is your calculator. Make sure your calculator's in degree mode before you start, and when you're ready, have a go. Okay, so we've just got 1 theta, so we don't have to change that. So sine is negative in the 3rd and 4th quadrant. Okay, you've got your all stations to central, and then you've got your formulas. Theta, 180 minus, 180 plus, 360 minus. Okay, so what we do is pretend we've got a first quadrant answer. So turn your calculator on, make sure it's in degree mode, put points, go shift, sine, 0.68 as a positive, and I didn't actually say what accuracy, so let's just go to nearest degree, so we'll go nearest degree. So I should have said that at the start. Alright, so for the first quadrant, theta equals 43 degrees. Okay, so that's not the right answer, but we need to use it. So in the third quadrant, theta equals 180 plus 43, which is 223. And in the fourth quadrant, theta equals 360 minus 43 equals 317 degrees. And you can test your answers. If you just go sine 223 and sine 317, which I'll do just to make sure I'm right, sine 223, and you get about the right answer. Okay, so you can test your answers. Okay, so in looking at the second one, it's a bit harder. Okay, so I've got some brackets to do, so I've got to go 0 less than equal to 2 theta less than equal to 4 pi, and then subtract pi on 6 from both ends. So 6 is 24, so it's 23 pi on 6, which means I've subtracted a pi on 6 from both ends. Okay, so we've got cos is negative, so cos is negative in second and third quadrant. So this value here, we don't have to worry about that because that's not in the second or third quadrant. That's effectively the minus first quadrant, which is the fourth quadrant. But because I'm doing 2 laps, I've got to keep going. So I've got second, fourth, and then 6th and 9th quadrant. So I've got 4 answers to go through. Okay, so when cos equals root 3 on 2, that means that, pi on 6 is our value, but that's not the right answer because that's in the first quadrant. So I do 2 theta minus pi on 6, which is what the bracket equals. So you get in the second quadrant, you subtract pi on 6, so that gives us 5 pi on 6. To get to the third quadrant, we add, so we get 7 pi on 6. And then to get the 6th and the 9th, let's go back to these numbers and add 2 pi. So 2 6s are 12, so I'm going to add 12, so I get 17. And add 2 6s are 12, so add 12 again. Okay. Now, so they're my answers for the bracket. And then, so 2 theta, I'm going to add pi on 6. So that gives me 6 pi on 6, 8 pi on 6, 18 pi on 6, 20 pi on 6, which I'll cancel down before I move any further. And 10 pi on 3. Okay, so that's what 2 theta equals, and then just divide through by 2. That's 2 pi on 3, 3 pi on 2, and 5 pi on 3. So that's as hard as you're going to have to do, that sort of question. Okay, moving along. Okay, so compound and double angle formulas. So this is important information. Just see if you can work out what that means. It's important. And when you're ready, have a go. Okay, so this means that we're in the first quadrant. And there's different techniques, but probably should draw a triangle. Okay, that's theta. And we've got, that's the adjacent. And that's the hypotenuse, 4 over 5. So using Pythagoras, that side is 3. So 3, 4, 5 triangle. So sine theta equals 3 over 5. Straightforward. Now, cos 2 theta is one of the double angle formulas. And just reminding you, you've got cos A plus B equals cos A, cos B minus sine A, sine B. So the cos 2 formula is cos squared A minus sine squared A, because A and B are the same. So what have we got? We've got 4/5 squared minus 3/5 squared. So 16 on 25 minus 9 on 25 equals 7 on 25. So that's the answer, 2 cos 2 theta. Okay, moving on. Okay, find the exact value of tan 15. So this is, what you're going to do here is you're going to use your tan A minus B formula. Okay, so have a go, and when you're ready, come back. Okay, so to get 15, 45 minus 30 equals 15, or 60 minus 45 equals 15, and it doesn't matter which one you use, you'll get the same answer. Excuse me. So, from your formulas, you've got, so I'm going to use the first one. So I've got tan 45 minus tan 30 over 1 plus tan 45 tan 30. That's the formula. Okay, so the formula match on the top and opposite on the bottom. So we've got some maths to do. Like at this stage, tan 45 is 1, tan 30 is, sorry, not root 3, it's 1 over root 3. Over 1 plus tan 45 is 1, tan 30 is 1 on root 3. Okay, so at this stage, if you can't figure out what to do, okay, you just leave it like that, but there's a bit of simplifying to do. So on the top line, the common denominator is root 3, so this number will turn into root 3 minus 1, so that's the top. Now 1 doesn't change, this has to change to a root 3 as well, so this will turn into root 3 plus 1, okay, and then the root 3's can cancel out, so you get root 3 minus 1 over root 3 plus 1, and again, that's, if you need to, I think just leave it at that, but theoretically you could rationalise the denominator by multiplying by what we call the conjugate. So root 3 plus 1, the conjugate is root 3 minus 1, and that'll get the third off the bottom. So what we're doing here is we're just multiplying top and bottom by the same thing, the conjugate, and what happens is you've got on the bottom a plus b, a minus b, which is a squared minus b squared, so then that turns into a 2, and on the top line you've just got root 3 minus 1 all squared. So that is the perfect answer if you can get to that, but you know, if you left it like that, I think that'd be fine. Okay, moving on. Okay, so we've got some year 9 trigonometry, so zip through this as quick as you can. Make sure your calculator's in degree mode. Okay, so we've got the angle here, so that's the opposite, that's the hypotenuse, that's the adjacent. So we've got adjacent and hypotenuse, so we've got a cos question, so cos 37 equals adjacent over hypotenuse, so we've got a division question, x is on the bottom, so we have a divide. Turn the calculator on, make sure it's in degree mode. Cos 37, and that equals 6.3 centimetres to 1 decimal place. Okay, next one. So we've got opposite, hypotenuse, adjacent. So this time we've got a tan question. So we've got tan theta equals opposite over adjacent. So we've got tan minus 1, 3/5. Okay, shift tan 3 over 5 equals, and degrees, minutes, seconds. So we've got 30 degrees, 57 minutes, 49.5 seconds, and we want nearest minutes, so it's 30:58. Okay, moving on. Okay, so I've got non-right angle trig, so this is the sine rule and the cosine rule. You need to work out which ones is applying to which. Pause, and when you're ready, come back. Okay, so we've only got one angle, so we can't use the sine rule, so it must be a cosine rule question. So we've got x squared equals 5.1 squared plus 4.6 squared minus 2 by 5.1 by 4.6 times cos 37. Okay, so 5.1, it's a bit of buttons pressing, plus 4.6 squared minus 2 by 5.1 times 4.6 times cos 37. Okay, so we get 9.698, but we have to square root that number, and we get square root answer equals, and we want one decimal place, so it's 3.1 centimetres. Okay, so most common mistake is to forget to press the square root. So that number there is not the answer, it's the square root. Okay, so next one, I've got two angles, so I can use the sine rule. Okay, so I'm trying to find the angle, so I'm going to put the angle on top. So sine theta over 8.6 equals sine 25 over 6.9. So the 5.1 is just there to confuse you. So sine theta equals 8.6 times sine 25, 6.9, and theta equals sine minus 1 of that number. And let's go. I'm going to go shift. I'm going to do shift sign, and I'm going to open up a bracket. 8.6 times sine 25 divided by 6.9, close bracket, and degrees, minutes, seconds. So I think the answer is 31 degrees, 47 minutes, 8 seconds, and I want nearest minutes, so that's 31:47. Okay, does that make sense? I've got 6.9 opposite 25, so 6.9 is smaller than 8.6, so I'm expecting to get a bigger answer to get a bigger side, and 31 degrees is bigger than 25. So yeah, that makes sense. Okay, moving on. Area of a triangle. Find the area to two decimal places. Pause, and when you're ready, come back. Okay, area equals half AB sine C. So you've got two sides and the included angle, two sides and the included angle. So that number you don't use. So we've got a half times 6 times 7 times sine 39. So just put in your calculator. 39. And we want two decimal places, so it's 13.22 centimetres squared. Don't forget the units, you will be penalised otherwise. Okay, radians and degrees, convert 40 degrees to radians, blah, blah, blah. Let's have a go. When you're ready, come back. Okay, so 40 degrees equals 40 times pi over 180, and that equals 2 pi on 9 radians. So you won't get penalised for not putting the units in, but that's what the answer is. Okay, next one. Pi is 180 over 12. And so that equals 15 degrees.